we are going to learn about the topic permeability of stratified soils. So before we go on to the main topic, we will learn the basics of what is permeability. So for learning the basics of permeability, you should know what is a soil and what are soil grains. So you know what is soil grains, and the arrangement of soil grains together forms the soil, and there are void spaces in between them, and when the water flows through these void spaces, it causes the flow of water in the soil. The ability of the soil which allows the water to flow through is called as permeability. Okay, permeability is the ability of the water to flow through the soil. Okay, we have all learned these basics, and the basic equation that we use for permeability is Q is equal to Ki into A, where Q is the discharge, K is the coefficient of permeability, I is the hydraulic gradient, and it has an equation equal to H by L, where H is the head loss and L is the length of flow of water. And the main point to be noted is L is measured along the direction of flow. Okay, the L is measured along the direction of flow. And in the main equation, A is the area of cross section, and this area of cross section is measured perpendicular to the direction of flow. Okay, the area of cross section is measured perpendicular to the direction of flow. Now we come on to the topic. So in nature, the soil is present in various layers. Okay, we know that the soil is stratified, and each layer of soil will have different properties. So based on that, the permeability of the soil has to be determined for each layer. Okay, so when we have multiple number of layers, it becomes very difficult to find the permeability of each layer, to find the discharge of each layer, and hence to find the total discharge. So to avoid those, what we will do is we find the average coefficient of permeability. Okay, to avoid this difficulty in calculating the discharge for each layer, what we do is we find the average coefficient of permeability. Okay, what we do is we find the average coefficient of permeability. So for finding the average coefficient of permeability, the main factor which we have to consider is the direction of flow of water. Okay, the main factor that we have to decide, which decides the average coefficient of permeability, is the direction of flow of water. Okay, so we assume that the soil has multiple layers. Okay, so we name them 1, 2, soil number 1, 2, and 3. All these soils have different properties. Okay, so their coefficient of permeability values K1, K2, and K3. Okay, so depending on the direction of flow, that is whether the flow is along the direction of stratification or whether it is perpendicular to the direction of stratification, the average value changes. Okay, the average coefficient of permeability changes based on the direction of flow of water. Okay, so if the flow of water is along the direction, we find the horizontal coefficient of permeability, which is marked as KH. Okay, we find it as the horizontal average coefficient of permeability, which is KH, or it is also known as coefficient of permeability in the parallel direction. So when the flow of water is along the stratification layers, it is measured marked as KH, and when the flow of water is perpendicular to the flow to the direction of stratification, it is KV. Okay, when the flow of water is perpendicular to the direction of the layers, it is marked as KV. So what we have to learn here is how to find KH and KV. Okay, that is how to find the horizontal coefficient of permeability and the vertical coefficient of permeability. That is the main aim in our topic. Okay, so first we learn about the horizontal coefficient of permeability. So we will draw the experimental setup. So this is the experimental setup that we are going to that we have drawn for showing the for determining the average coefficient of permeability when the flow of water is in the vertical direction. So this is the water source, which is in the higher direction. So you allow the water to pass through the soil layers marked as 1, 2, 3, 4, and 5. There are 5 layers that we have assumed here. So the water is flowing from this direction to this direction. Okay, from the upper reservoir to the lower reservoir, and the water is being collected in the lower reservoir, and you can find that the difference in the water level, that is the head loss, is small h. and the area of cross section. So as the water is flowing in this direction, so the area of cross section comes like this. Okay. So this is in this direction is a soil sample. But the water is flowing in this direction, so this will be the area of cross section that I have to consider. So we can consider it to be of unit width, the soil sample to have unit width, or you can consider the width of the soil sample to be capital B. Okay, or you can consider the soil sample to have width of unit B and the height of cross sections. Okay, the total height is for the entire sample it is H, and for each layer we can take it as capital H1, capital H2, capital H3, capital H4 and capital H5. So for finding the average value for each layer, that is the area of cross section for each layer, when we take it is B, that is the inner this dimension, that is B into H1, this height. So if you are dividing it into 5, what do you mean? So this width B into H1, B into H2, B into H3. So likewise you can find the area for each layer, and the total height of the sample is capital H. Okay, the total height of the sample is capital H. So I am dropping this diagram so that I can draw the write the explanation for derivation. So referring to the previous diagram, we could see that the discharge through all the layers is the total discharge is the sum of discharge through all the layers. Okay, from the previous equation we could understand that the total discharge of the entire soil system is the sum of all the layers. So we already know that the hydraulic gradient is a constant. So the value that we have to have is KH. The total discharge we take it as KH into I into area of cross section. I have already told you the area of cross section is B into total height of the sample. B is the constant width that we are taking for the entire soil sample, and that is equal to K1 into hydraulic gradient is constant, B is constant into H1, okay, plus K2 into hydraulic gradient is constant, B is constant into H2 plus so on up to n number of layers. Okay. So this is the equation. So as I and B are constant on both the sides, it can be eliminated, and then we find the value as KH into H is equal to K1 H1 plus K2 H2 plus K3 H3 plus so on up to Kn Hn. Okay, and from this equation to find the KH value, we can bring the H to the other side. So KH is equal to K1 H1 plus K2 H2 plus K3 H3 plus so on up to Kn Hn, the whole divided by height, capital H, and this capital H is equal to H1 plus H2 plus H3 plus so on up to Hn. The main thing to notice, this capital H is not the head loss but the height of the soil sample. Okay, this height H is the height of the soil sample measured perpendicular to the direction of flow. Okay, which is measured perpendicular to the direction of flow. Okay, so I hope you can have understood. KH is the average coefficient of permeability when the flow of water is parallel to the direction of stratification. That is, in most of the cases it will be in horizontal direction. That is why we mark it as KH. Okay, it is the water when water is flowing through the direction of stratification. That's why it is called as KH. Next, we have to learn about the topic coefficient of permeability in vertical direction. Coefficient of permeability when the flow of water is in the vertical pressure L in the direction of flow. So this total head loss is H, and it is divided among the entire height of I. Okay, so the total average head loss is I is equal to H by small h by capital H. But when it comes to each layer will have head loss H1, H2, H3, H4 and so on. Okay, so if we are having a tube connected in each layer, we can see that the head loss will be different. So for the ease of our experimentation, we are just connecting a single tube. Okay, but in field, that is, if you take each layer and connect a tube, we can see that the height of water level will be different in each tube. So due to shortage of space, I am going to erase this page. Please keep the diagram in mind. So downward